What's up, guys? The first part of today's video is about identifying and using special pairs of angles. I have already listed out 3 different special pairs of angles here. I'm going to go over them with you. The first special pair of angles are called adjacent angles. Remember, the word adjacent means next to. So basically, they're 2 angles that lie in the same plane. They have a common vertex and a common side, but no common interior points. So basically, they don't overlap. When they say they have no common interior points, the angles cannot overlap. So for example, we have angle ABC and angle DBC. These 2 angles share the vertex point B, and they do not share any interior points. They share the common side, ray BC. Something that is not an example or a non-example of adjacent angles would be an example such as angle ABC and angle ABD. Notice these are not adjacent angles because they share the common interior points, all the points that lie between ray BA and ray BC. All these points are in common with both of the angles. The 2 angles are overlapping. Therefore, it is not an example of adjacent angles. The next special pair is called a linear pair. A linear pair, you can think of it because linear, think line. So basically, it's a pair of adjacent angles, but the non-common sides are opposite rays. So opposite rays means they are forming a line. Think back to that vocab word. So for example, angle 1 and angle 2 form a linear pair because the non-common sides form a straight line. They cannot be overlapping. They still have to be adjacent angles. A non-example would be something like this, angle 3 and angle 4. The reason this is not a linear pair is because their non-adjacent sides or their non-shared sides do not form a straight line. So since these are not opposite rays, angle 3 and angle 4 are not a linear pair. The last special pair are called vertical angles. Vertical angles are 2 non-adjacent angles, so they are not next to each other. That's what non-adjacent means. And they're formed by 2 intersecting lines. So for example, if you could draw 2 intersecting lines, so 2 lines that intersect, the angles that are not next to each other. So for example, angle 1 and angle 3, they are not next to each other. Those are called a vertical angle pair. The next example would be angle 2 and angle 4. This is another example of vertical angles. A non-example is when there are not 2 lines forming the angle. So notice this line that I have highlighted is a straight line. However, these other 2 rays are not opposite rays. That is not a straight line. So angle 2 and angle 4 are not vertical angles because they're not formed by straight lines. Similarly, angle 1 and angle 3 are not vertical angles because they are not formed by 2 straight lines. So just be careful, make sure those are formed by straight lines. Let's do an example of identifying these in a diagram. So it says, name an angle pair that satisfies each condition. Part A, 2 acute adjacent angles. you need to know the word acute means that it has a measure less than 90. And you need to know this new vocab word adjacent, which means that they are angles that are next to each other, non-overlapping. So we're going to look for two angles that are less than 90 degrees, non-overlapping, but next to each other. So the angles that stand out to me, let me change my highlighter color here, would be these two angles. Angle OJN, that's very clearly an acute angle, and angle NJM. That's also clearly an acute angle. I will highlight them together so you can see them next to each other. Notice they share ray JN. This is their common side, but they are not overlapping. So our answer could be angle OJN and angle NJM. We could also name angle NJM and another angle. What other angle do you believe is acute and adjacent to angle NJM? If you responded angle MJL, you are correct. This is another acute angle, clearly has a measure less than a right angle, and it shares the side ray JM with angle NJM. So we could also answer angle LJM and angle NJM. The next one says two obtuse vertical angles. So remember, vertical angles have to be formed by two intersecting straight lines. So we'll look at our picture and find two straight lines first of all. These two lines are intersecting. You can ignore these rays here because they are not forming the two straight lines. So we want the obtuse vertical angles. So do you think we should choose angle HJK and angle NJM? Or should we choose angle HJN and angle KJM? If you said angle HJN and angle KJM, you are correct. Those two are the pair that are very clearly obtuse, which remember means greater than 90 degrees in measure. Alright, I'd like you to try these two practice problems. Pause the video now. Here are the answers. Check your work. Next, I want to go over some special pair relationships with you. So something that's special about vertical angles is that the two angles are congruent. So for example, if we look at angle 1 and angle 2 here in this model, we know that those two angles are congruent. In other words, they have the same measure. Next, you might already know these two. The first one, two angles that have a sum of 90 degrees. Do you know it? These are called complementary angles. So for example, we could look at two angles that are adjacent, such as in this diagram, angle 2 and angle 1. These two angles clearly make a right angle. They have a sum, their measures have a sum of 90 degrees. Or the angles don't have to be adjacent, so you could also look at angle A and angle B here. Clearly 30 degrees plus 90 degrees, plus 60 degrees would add up to 90 degrees. So you could say that angle A and angle B are complementary. The next vocab term, two angles that have a sum of 180 degrees. Do you know this one? These are called supplementary angles. For example, you could look here at angle 4 and angle 3. Those clearly have a sum of 180 degrees because they form a straight line. Or they, again, do not have to be adjacent, so you could look at angle C and angle D since their measures have a sum of 180 degrees. Those two, angle C and angle D, are supplementary. Finally, for a linear pair, we know that the two angles must always be supplementary in a linear pair. So, for example, angle ABC and angle CBD are supplementary because they form a linear pair. Anytime two angles form a linear pair, they are supplementary angles. Let's do an example together. You have to know your vocab to be able to solve this example. It says, find the measure of two supplementary angles if the difference in the measures of the two angles is 18. So the first fact that we know is that we're finding two measures of two different angles. So we'll just call these angles angle A and angle B. So I know that they are supplementary angles. So I know that their measures would have to add up to 180. So the first equation that I can write is the measure of angle A plus the measure of angle B equals 180. Since I'm finding two different variables, I have the measure of angle A that I'm trying to find and the measure of angle B that I need to find. Since there are two variables, I need two equations. Lucky for me, I see that I have another piece of information. It says that the difference in the measures of the two angles is 18. Difference means subtraction. It does not matter which angle you subtract from which because we don't know which angle is larger. Clearly, if we write our equation like this, angle A is the larger angle, but it really doesn't matter. You could do A minus B or B minus A. Now that we have a system of equations, you need to use your algebra to be able to solve it. Luckily on this one, we have one positive measure of angle B and one negative measure of angle B. Since these coefficients are opposite, positive 1 and negative 1, I would like to use elimination method to solve this system of equations. To use elimination, you add your two equations together. So I have one measure of angle A plus one measure of angle A. That gives me two measures of angle A. Next I have one measure of angle B minus one measure of angle B. 1 minus 1 is 0. These two cancel out. That's why I'm using elimination. Finally, I have 180 plus 18. That gives me 198. Now I have two measure of angle A equals 198. To solve this, I need to divide both sides by 2. Therefore, I get the measure of angle A equals 99. Once you have one of your answers, you can go back to one of your original equations to find the measure of the other angle. I'll just choose this equation. So I have the measure of angle A plus the measure of angle B equals 180. Now that I know the measure of angle A is 99, I'm asking myself, what do I have to add to 99 to get 180? I can solve that by taking 180 minus 99. That gives me 81 for the measure of angle B. So now that I have my two angle measures, I could check my work by seeing, is the difference in the measures 18? Let's see, 99 minus 81, is that equal to 18? Yes. Also, do the two measures have a sum of 180? Yes, they do. I'd like you to try this practice problem on your own. Next, we are going to talk about perpendicular lines. You may already know what this means, but let's go over it. Perpendicular describes any lines, segments, or rays that form right angles. This symbol here, an upside down capital T, means perpendicular to. So, for example, we could write an a statement that looks like this. Line L is perpendicular to line M. I see that line L and line M are intersecting lines, and they're forming a right angle, which is shown by this red square in the corner. That's why I can say line L is perpendicular to line M. See if you can figure this out. Perpendicular lines intersect to form blank how many right angles? If you said 4, you are correct. Perpendicular lines intersect to form 1, 2, 3, 4 right angles. Let's do a practice problem with perpendicular lines. It says find x and y so that line PR, which is this line here, and line SQ are perpendicular. I will look at the value of y first. If these are perpendicular, that means that angle PTQ must be a right angle. Remember, a right angle has the measure of 90 degrees. So I know that the measure of angle PTQ must be equal to 90 if they're going to be perpendicular. Now I can fill in, substitute 4y minus 2 for the measure of angle PTQ. And now it's just an algebra problem. Add 2 on both sides, divide both sides by 4. You get y is 23. Similarly, if these are going to be perpendicular, I know that the measure of angle STR must be equal to 90. On this one, it's a little bit different. Angle STR is split up into angle STW and angle WTR. So I can write this equation, the measure of angle STW plus the measure of angle WTR would have to be equal to the total, the measure of angle STR. I can substitute in all of my expressions and values now. The measure of angle STW can be represented by 2x. The measure of angle WTR is represented by 5x plus 6. And finally, I said that the measure of angle STR must equal 90, so I can put 90 in for that. Now it's an algebra equation. Combine your like terms, subtract 6 on both sides, divide both sides by 4, and you should get x is equal to 12. Pause the video and try the practice problem below. Here's the solution. Answer this reflection question now, please. Have a great rest of your day. Bye, everybody.